All right, I will introduce Dr. Ennemoser, who is our presenter today. Benjamin Ennemoser is an assistant professor at the Texas A&M University Department of Architecture, where he leads the AI Plus Architecture Lab. He has previously taught and lectured at UCLA, University of Innsbruck, and the University of Applied Arts in Vienna, among others. He has received several fellowships and grants, including a research grant from the Academy of Performing and Visual Arts, a CRS Probst grant at Texas A&M, and the START grant from the Austrian Federal Ministry of Arts and Culture. His research and teaching were awarded at the Architizer Vision Award, the Undergraduate Faculty Award for Outstanding Contribution to the Graduating Class at Texas A&M, and the Texas Society of Architects TXA Studio Award. He is the 2024-2025 Montague Center for Teaching Excellence Scholar and is the endowed Harold L. Adams 61 Interdisciplinary Studies and Architecture Professor at Texas A&M University. Ennemoser was elected as a member of the city's Generative AI learning community and is an elected member of the boards of directors at the Association for Computer-Aided Design in Architecture, United States, or ACADIA. His research in computational designs, robotics, and artificial intelligence in architecture was published in international journals, books, and conferences such as IGAC, ACADIA, ECAADE, and ACSA. He presented his research at academic institutions such as the AA London, EPFL, Topman College, and GIT, and UPenn. He is a licensed architect and also founded his practice in 2016. He recently collaborated with Google R&D for the built environment, Carvana, and Chancellor GXT as a technology consultant and design lead. Dr. Ennemoser, feel free to start your presentation.
Awesome. Thank you very much for the generous introduction that that covered pretty much everything. So welcome everyone. My name is Benjamin Ennemoser, and I'm an assistant professor at the Department of Architecture with a specialization in computational tools. And in the last, I would say, 5 years or 6 years even, focusing on artificial intelligence. And I will share today how my personal research is guided and how this research makes it also into the classroom, and how certain ideas, certain challenges, opportunities from my research will also help me to drive how I implement generative AI and AI tools with my students, and basically subsequently also like bring that back into the research and how that goes in a full circle and hopefully is beneficial for everyone involved. But without further ado, let me see. Here we go. So the AC, architecture, engineering, and construction industry is a very rich discipline, or a very rich territory of data, ranging from before you even start a project, calculating the feasibility of a project, while you're scanning the site, all the way to designing the building, sharing information with each other. During the full life cycle of a building, like we produce tons of data, and data can be used, but then as well as like documenting the building all the way into once we bring or put the building basically at the end of its life cycle and demolish it. So there's a wealth of data that is in our discipline that we can work with. But the question is, how do we work with, and how do we also make our students aware that this data could be their future kind of like gateway into innovation, but also applied research in the field. Just as a very small summary, AI, it is out there. It's not something new. And my students sometimes are surprised about, oh, we're working with AI. That's something I've never worked before. But then I always ask the question, who of you applied to the school using a web browser like Google or Yahoo? Everyone did. And I said, okay, well, that is the first time, for at least the first time, or might be one of the first times you were introduced to AI, because that search engines, they use AI to customize whatever you see. Or I asked them, who of you has seen an autonomous car, like an electric car, like a Tesla on the street? Everybody raises their hand. Well, you have seen Tesla, and AI has seen you, right? So AI is not something that we are not touched already. It's something that influences and is in our lives every day, although we might not know it. But the problem is, many of these tools, many of these AI tools are done by computer scientists, and they're not done disciplinary, for example, to us in architecture. So what you see here, this was one of the first research of generative AI, how computer scientists at Google try to generate goldfish out of a huge image data set. And of course, we might ask ourselves, why is this relevant to us? Or here, when Google researchers try to hybridize different, I would say, call it typologies, from a chicken all the way to a dog. These are things, that computer scientists might be interested in, but we as architects, we need to look for the opportunities in these tools that are done outside of our discipline and find ways how we can instrumentalize them for us. So that being said, and thinking back that we as architects, we sit on a wealth of data that is sometimes not always shared, and I will come back to that. But yet, if we have the right data, we can also use generative AI and pretty much every AI tool in the field of architecture and find an application for that. I personally always see the architect as the curator, like the curator of the data, and that's something also that I started my research in that notion, but always try to distill it back to my students, that you as the architect, when you're creating this data, you have a certain responsibility, but also opportunity, how a machine is gonna learn and extract features. Part of my research, I was working with satellite imagery from remote sensing technology. There was a research project called ML City that is also published in Machine Learning and the City. And essentially, where we deployed thousands of images from satellite imagery to learn urban typologies. And then most importantly, we go into a territory where we try to hybridize urban typologies, like for example here, Barcelona and Los Angeles. Barcelona is an iconic urban model, very dense with a very distinct kind of grid and layout. And Los Angeles, on the other hand, is a very suburban model, right? That is has not the same density as Barcelona. But what would happen if you would clash these two cities, and what could you learn of hybridizing two very different typologies, urban and also socioeconomic environments? Or the same with if you try to fill or hybridize Barcelona and Marrakesh. Marrakesh, it's a grown city, it's not a planned city. Barcelona is planned. Marrakesh has these courtyards for ventilation, for cooling down buildings. So what if, for example, Barcelona needs a different typology, but stay in the same grid, and how that could look like? Or if you mix multiple cities together, like Delhi, Los Angeles, and Portland, how do certain features, certain aspects of one city can be transplanted to the other ones, and try to look and speculate on more resilient outlooks? Or another experiment we did here, in a city with to depict Portland, Oregon, into a garden city by featuring on a more planetary level. And that already goes into the next kind of aim what my research does, meaning how can we as architects for the first time really harvest data across and equitable across the planet, meaning through remote sensing technology. Because this research that was also published in iCheck, the International Journal of Architectural Computing, discusses that through remote sensing technology, it doesn't matter if I want to have data in Texas, in Italy, in I don't know, Germany, in Korea, wherever, I can retrieve, with a few exceptions, the same data at the same speed and the same accuracy. And then we are trying to create these planetary data sets that could depict different possibilities, different urban structures, but also not just train urban landscapes, but also train natural landscapes or agricultural landscapes, and then figure out what are the figure ground, what are the patterns, what are the infrastructures, as in a second step through semantic feature detection that AI uses. In the next step, we also developed Convoluted City that went one step further in planetary data sets, and we tapped into the notion of architects have for a very long time tried to map the world, map cities, map territories, right? But it's always a very one-dimensional, one-layered system. So we are harvesting the potential of AI and generative AI to train data sets across the world from different scales, different zoom-ins, different patterns, different, I would say, labeling, let it be from an urban center to a rural area to agricultural landscape, and how can we layer them almost like a multidimensional flip book, and then find connections between these, find latent connections also between these territories. And these are visualized into these resin prints, where each slice is a different step of an AI's latent memory that was trained on, again, around the globe, and multiple different kind of like landscapes and satellites and inputs. And in that notion, my personal research is very much concerned about how does a machine see and perceive architecture and the built environment? Because before I don't know how this entity, this machine, is able to harvest information, it's hard for me to also deploy it as a useful tool and predict new possible kind of like digital twins, urban scenarios, or even like resilient hybridizations of architectural typologies. In that notion, we also were very much invested in making the step between 3D into, so from 2D images to 3D images. So we replaced the 2D image data set with 3D building data sets, and made it almost an archaeological kind of like approach. How can a machine detect spatial features, materialities, and so forth across thousands of samples? That these samples are across the whole architectural history from the last 3,000 to 4,000 years, and essentially also detect what are the origins of certain architectural elements, or what is the repetition of certain architectural elements, or how does a machine, for example, detect architecture in its third dimension, and always like with also a take on like what is the materiality, and how this materiality could lead to new conclusions around the built environment. So here we see some examples of reconstructions where an AI was looking into 3D GANs or 3D data sets and tried to move forward. So everything I showed you so far is by custom data sets. So me and my team, we are creating these data sets. But then about 2 years ago, a complete new model came onto the stage, not just in architecture, but very influential in architecture and across all disciplines, something called like generative AI or diffusion models, which are all text-based, so to say, text prompt, but also they are all pre-trained. So meaning I do not create the data set, right? But I'm relying on a data set that is out there in the internet, but still I could use it like here to depict architectural houses, architectural proposals, architectural facades, materiality, and so forth. So this was a real game changer in the world of AI, because all the research I've shown you before is very, very tedious, you know, and it's a very long process. But with generative AI, all of a sudden, it was very easy to also implement AI tools into the classroom. So before I went into the classroom, I did one of my own projects that was funded by the AVPA and the CRS Center that's called Diffuse Countryside, that looks into how can I use architectural samples from here in College Station or in rural areas in Texas, and how can I ask a generative AI to depict it into a contemporary style. And although these designs look very, very compelling and they look really, really out there, one thing came clear in this research. When it comes to the countryside or rural communities, generative AI and pre-trained data sets are biased. They are focused way more on urban landscapes because they have a much bigger digital footprint, right? So there is a certain issue towards that certain regions, certain communities might not be represented equally, and it might yield interesting results, but these results might not be truthful to the ground truth and to the communities that live there. So that was also published in the Pool magazine from UCLA. And then tapping into this kind of like first step of diffusion models, I collaborated with my colleague James Michael Tate, and in our 4 or 6 design studios, we said, let's use these diffusion models and bring it into the classroom. So we made the task, how can a generative AI depict specifically mass timber CLT interiors and exteriors of affordable housing? So how do we need to do prompt engineering with our students to use it as a design tool, as a sketching tool, right? But a sketching tool that is much more real, has much higher fidelity, is faster, and also like instantly available. So we tasked our students to sorry, before we tasked us, we went with them on a field trip to East Texas, and we showed them the mass timber industry that is emerging right now in East Texas. We saw small family-owned sawmills all the way up to large-scale kind of like mass production, and then using that knowledge about this kind of like material economy and also like circular economy in Texas around mass timber. There's a video. We tasked them to develop prompt engineering for interiors that are all made out of wood, mass timber, CLT, and so forth. And learning from that, we got a whole kind of like cookbook of keywords that one needs to use if you want to depict successfully interior spaces, or depict a wood language that is feasible, that is realistic, and also that could be shared across not just students but also practitioners in the industry. We did the same exercise for exteriors. Like, what are the keywords? What is the prompt engineering in generative AI that one needs to know specifically to depict CLT and mass timber exteriors? And also, we got again a whole series of keywords, and also we track them in terms of their relevance and how many times that needs to happen, and so forth. So students gained a whole lot of insights in terms of like, how do I do prompt engineering? How do I work with generative AI? What are the opportunities, but what are also the challenges in terms of interior spaces, exterior spaces, and a very specific materiality in architecture. And then after that, students used the depictions of generative AI to create their own designs. So they derived from the generative AI depictions and almost used them as a sketch to start to make the full three-dimensional design and the housing proposals, ranging from massing, ranging from facade elements, from materiality, but also from detailing, right? How a raft is detailed, how our brace is detailed, everything in the notion of mass timber and CLT. And yeah, so that was our first attempt to use generative AI, and the results were very compelling. And we also got a chance to make a peer-reviewed paper out of that and present that at the ACSA and the AIA joint research conference at the University of Massachusetts in Amherst. The AIA is the American Institute of Architects, which is our biggest institution that oversees accreditation and so forth. And the ACSA is also the agglomeration of collegial architectural colleges in the United States. So it was a very important venue for us to present that. Another research that we also presented in a research conference and in a peer-reviewed paper was at the National Conference on the Beginning Design Students last year, where we presented our second-year undergraduate design studio, where students were asked to design a chapel in rural Texas. We had about 130 students. James Michael and myself were the coordinators of the second year. We had about 8 sections. We had six more faculty also teaching that. And across the board, we tried to use generative AI to help students in a very early beginning of the design career to very fast and very quickly depict these chapel designs, but at the same time also give them the opportunity to get to know more, like, how do I do prompt engineering? How can I use external precedents, architectural references into that design process? And as always, like we always go on a field trip. So second year, we go to Dallas-Fort Worth. On our field trip, we looked at an array of like civic buildings, like museums and chapels, that led the students to take pictures, which later on were fed to the generative AI to also create new input, but also get an understanding of or like a first-hand experience of architecture in their particular typology, what they have to design, namely churches. We did some precedent analysis. So this is like where students analyzing existing buildings and basically trying to describe them. And then what they have learned from these buildings, we sent them into, again, Midjourney, where they had to then ask for depictions of chapels in rural Texas. Now, I will show you a whole kind of like series of chapels that they came up. Some of them are like out there. Some of them are like very, very expressive. But at the same time, it was an amazing influence for students. And we also like made an exit survey with students and asked them, what have you learned? How useful was the AI? Was it useful? Was it not useful? And we got about 50% of the students saying, well, it was not needed, but it was great to have it. And the other 50% was my final output was instrumentally driven by generative AI. And each student agreed that the accessibility, the fidelity, and also the speed how to work with them is remarkable and like really, really enhanced their learning experience. And then also, like as you see here on the left, that is a image depicted by generative AI. On the right, you see a physical model done by the students for a final project. So we had some students that directly were inspired and modeled it after the image that was given by the generative AI to them. Or we also had students who vaguely took some ideas from the generative AI and made that into a design proposal. But there's a clear inspiration. So from literal translation to, I would say, a more abstract inspiration, we have the full spectrum in the results from the students that were able to then come to these final results as shown here. Obviously, we saw some more some more expressive executions of student design, but at the same time, we also honored that because we got just such good feedback from the students telling us that they were very, very happy about using the generative AI. And we do not really want to replace sketching, like that is traditionally very common, especially in early design studios. But at the same time, we also don't want to dictate that generative AI cannot take that over. So we are doing the same this year. I don't have the results yet because we have final presentation this week. So next semester, I could share what we have done this year. But all you have seen so far was when I went from my research into the classroom and then taking feedback from the classroom, going again into another research. So I want to end here with a small research project that is about eliminating bias of pre-trained generative AI for rural communities during early design phases. And the beauty is the students who worked with me in my undergrad classes, I hired them through internal and external grants to work with me on this research. So they got trained in generative AI. They discovered the opportunities, but also challenges. And then we together explored 8 mega regions across the US, urban mega regions, and also explored as many as rural communities in Texas. And we asked generative AI. So we uploaded images from real estate, like existing real estate, and we asked generative AI what it sees and where it thinks it is located. And we did that for about 3,000 to 3,500 samples across the United States. Again, urban versus rural communities. And what we have found out is no surprise. In terms of location, in terms of style, in terms of materiality, in terms of typology, in terms of usage, in terms of materiality. When it's in an urban context, it almost always knows that this is in Los Angeles, this is in Boston, this is in Arizona, Phoenix, but it almost always does not know where it would be in a rural community. It even makes up fake names. It even makes up towns that do not exist. It actually also becomes partially racist. It becomes partially very offensive towards the people who would live there. So we discovered a huge bias. I mean, it was obvious that there is the bias. We knew the hypothesis might be true, but throughout these 3,000 examples, and we just finished this research, so I only have a few maps that we draw. We just discovered like huge issues that are basically within pre-trained data sets when you work for rural communities. And also subsequently, we are now applying for research funding and going forward, and we are trying to augment these pre-trained data sets and look for best practices and solutions how pre-trained and generative AI, not just in practice, but also in the classroom, but in general, when working with rural communities and territories, that it can be more equitable, but also like more applicable. And most importantly for us, it's important that when we work with generative AI in rural communities, rural areas, we don't want that urban principles are being forced onto these regions or communities, because that would be devastating. So coming from research, going into teaching, and then going back to research, I hope I made the full cycle, and I'm looking forward to hear questions if there are some. Thank you very much.
All right, thank you, Dr. Ennemoser, for the presentation. Anyone feel free to ask questions, and I will stop recording.